this is a short video to help you revise how to do MR calculations. So this is part of quantitative chemistry. And this is relevant to you whether you are doing trilogy chemistry or you are doing GCSE. So it's relevant for everybody studying GCSE level chemistry, whatever course you are doing. So MR stands for relative molecular mass. And in order to calculate MR, what you have to do is you have to take, first of all, the formula of an element or a compound, and you have to add up the masses of all of the individual atoms. So relative molecular mass, so add the masses of all the individual atoms. So this is simply an adding up exercise, okay? So for example, if we take H2O, H2O contains 2 hydrogens and 1 oxygen. So what you need to do is you need to find your periodic table. Now mine is covered in all sorts of notes that I've made, so that's absolutely fine. And I find hydrogen, and I find that its mass number is 1, okay? And oxygen's mass number is 16. So what I'm going to be doing is I'm going to be adding 1 to 16, which totals 18. So that's the MR of water. If I have to do O2, that's 2 lots of oxygen. So I can either do 16 plus 16, or I can write 16 times 2. And the answer there is 32. If I want to do the MR of something more complicated, like for example calcium hydroxide, where I have this, I've got to consider how many of each of the individual atoms there are. Now if I look up the mass of calcium, I know it's 40. I've only got 1 of them, so that's fine, but this 2 means 2 of everything inside the brackets. So I've got to add on the mass of 2 oxygens. So actually the easiest thing to do is to pop it in brackets like that. 16 times 2. It's the same as 16 plus 16. And then I add on to that 2 lots of hydrogen. So 2 lots of the one which is hydrogen. So 40, 50, 60, 72, 72, 73. So I'm going to make that 74. I hope that's right. Check it. 40, 50, 60, 70, 72, 73, 74. Yep, I make that 74. So that's how you do MRs, all right? So you need to be able to do that whether you're doing higher, foundation, trilogy, GCSE. Doesn't matter, everybody's got to be able to do that. But once you've done MR calculations, you can then do mole calculations. So working out moles. Now, a mole is an amount of stuff. So like a dozen is 12, a mole is a large amount of stuff. The most often calculation that you have to do is to use this equation where moles is equal to the mass that you've got divided by the MR. Okay? The moles is the mass divided by MR. So, for example, if a question said to you something along the lines of, excuse me, wobbling my visualizer, how many moles in 22 grams of CO2, for example, okay? So there's a couple of parts to that calculation. You've got to, the mass is 22, but you've got to work out the MR. So first of all, do the MR CO2. So the mass of carbon is 12 plus 2 lots of oxygen. So it's 44 in that instance, okay? So moles equals 22 divided by 44. That's the calculation that you're doing there. I'm hoping that you can see that. Yep. And so the answer is 0.4. 0.5, okay? So it's 0.5 moles. Other arrangements that you may have to use for that formula is that the MR is equal to mass divided by moles, or the alternative arrangement where we make the mass the subject is moles times MR. So there you go, so it's a very quick whistle stop. This is how you do it, okay? This is the equation that you need to know, or it doesn't really matter which form you remember it in, but you need to be able to do the rearrangements. And then also for working at MR, you've got to know that you've got to add the masses of all the individual atoms together. Okay?